Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're back for the power supply repair, upgrade, whatever you want to call it, on this R300. And I think I've come up with a good solution. So there were some things that I thought were going to be issues, but turns out really aren't. Simple solution involves 2 tubes, getting a couple of 5AR4s, and 1 resistor. The rest of the parts that we need are just moved around inside the amp. And so let's get to fixing this amplifier. Okay, we're going to look at some schematics here. This is what I believe the original design was. And until I get one of the earlier amps, I can't be 100% sure. But looking at pictures, this is what it looks like it's wired like. We have a power transformer going to 2 rectifier tubes in a full wave design, which means the center tap here is grounded. Each one of these tubes is acting like a single diode because the plates are tied together, which cuts the load on each of the rectifier tubes in half. On these direct heated tubes, the high voltage DC comes straight off of the 5-volt filament. So each one of the tubes has a 5-volt connection to it. The 2 outputs are tied together on this rail. Goes through a single diode. Then it goes to the first cap, which possibly could be a 220 UF. I'm not 100% sure until I look at the circuit board. We're going to assume it is. This is the 4 Henry choke that they have labeled as such, but it actually measures 1.5 Henries, 35 ohms of resistance, and then it goes to this 330 UF, which goes to the B+. Okay, the amp I have in front of me is a modified version that they did these updates to because they were having problems with these tubes failing. So what they've done is they put a 10 ohm resistor on each side of the transformer to help take some strain and inrush current off of these tubes. Then they put this delay relay in, which waits for about 20 seconds before it energizes the high voltage AC to the tubes, but the AC going to the heaters is there. And so the tubes get all heated up, including the output tubes, before it clicks in the high voltage AC, which still gives a real surge of current through these tubes as it's trying to charge up these 2 big capacitors. I have a feeling that these resistors were put in place to try to mitigate this current surge. Then they put 2 diodes, 1 for each tube, to help keep the capacitors that may not have discharged from back feeding into the tubes on a hot restart. It's got the same 1 Henry 35 ohm choke, and again here's the B+ going to the rest of the amplifier. Now if you put a 5U4G tube in, it's going to have the same issues that this 274B has, given that it's a direct heated tube that almost instantly starts conducting current. And both of these tubes, unless you get the GB version of the 5U4, are not rated to deal with a capacitor this large as the first capacitor. Well, in a future video, I'm going to really go through rectifier tubes and capacitors and why they're important. But for this exercise, we're going to just look at the data sheets and try to make sure that we don't exceed the value. So we have 2 tubes sharing this 1 capacitor, so half of the load will be on each tube. So let's say that the maximum for this 274B is a 4 UF capacitor. You could get away with an 8 UF. You're not going to get away with 100 UF. So here's what I'm recommending we do for the power supply. We're going to replace the 274B tubes with this 5AR4 rectifier tubes, which are an indirectly heated rectifier tube, which means that it doesn't start conducting current until the heater warms up the cathode, which is not directly the filament. And so it slowly ramps in the voltage to the amplifier, which lets it charge up the capacitor slowly, which takes most of the inrush current strain off of the rectifier tubes. So we're going to leave this 10 ohm resistor on each leg of the power transformer. Goes to the 5AR4 tubes with the plates tied together. Then the cathodes come up, go through this diode. We're going to remove the 10 ohm resistor on each leg that it originally had. So then it comes up, the two diodes are tied together on this rail. So this is where our high voltage DC is sitting that hasn't been filtered yet. It's going to go through this 50 ohm resistor and then to the first cap, then through the choke, and then through this cap. So this whole section here is staying original. We're just going to be changing the components that are soldered to the pins, and we're going to be removing that relay board that was sitting right here in the circuit between the power transformer and the 5AR4 tubes. So we don't have a hot start power supply. We have a soft start because of the action of these indirectly heated rectifier tubes. This 50 ohm resistor helps offset the higher voltage that we see on our output here, because these are more efficient rectifier tubes. And with this power supply, we should see 400 volts on the plate of the 300Bs with them biased in the middle of the meter. So let me show you how to do these modifications so that these 5AR4 tubes work well and the voltage is correct at the plate of the output tubes to keep the 300B tubes happy. Okay, I showed you in the schematic why we're doing this, and now I'm going to show you how to do it. First you want to do is, there's two screws. I went ahead and took these out and screwed them back in, but you can see there's a screw here and then there's a screw here, which you can't really see, but holds this board down to the chassis. So you want to pull these out, get this board loose, and then put those screws back in. They hold the transformer down, the power transformer. So now we're going to come in here and disconnect all the wires that hold this delay board in. And you just heat up the pins. Make sure you take the tubes out. There's no point in heating up the tubes. And then you got these two little wires. Now we do want to make sure that these two wires here stay connected. You can see that one kind of came loose, so just make sure that those are soldered in good to those low voltage wires, because those go over to the board over here that powers up all the other electronics. And there we go. Next, we're going to remove these 10 ohm resistors, and then we're going to remove this connection from the diode and swap it over here, which is the output of the tube. So let's do that. I'm going to zoom in here so we can get a little better shot. And it looks like they bent this pin over to mechanically fasten it. So it might take a little bit of work to get that off. Honestly, I think it's going to be easier just to clip that guy off. Get some needle nose and bend that over. And put it through that hole. And we're going to do the same thing over on this side. Snip this off. Just like that. So now we have the output of the rectifier tube going through this diode to this wire here. And you can see, then you have this wire here that connects the two outputs. Same thing over here. You have this pin, goes through the diode, and then goes to this output wire. So this point right here is the common output of both of the rectifier tubes. So the last thing we're going to do is we need to put 50 ohms of resistance from here to this pin and then move this wire, which goes over to the choke, from this pin to that pin. We want to put 50 ohms of resistance between here and here. Now I'm going to use two 100 ohm 2 watt resistors just because that's what I've got sitting here on my shelf. You could put like a 5 watt wire wound resistor across here. It's going to pull about 1.5 watts, so you want to have at least double that. And I think 3 watts is probably the minimum I would do, but I think 4 to 5 is probably more ideal. So let me solder those in place. And the easiest thing to do here is just snip these off. Strip that one back. Tin that. I'm going to stick it through from the back side. So again, this wire here is tying the two outputs together. Then we're going to put this one down the bottom of that, and then we're going to put our resistance across these two pins. Now understand that the only pins that the rectifier is actually using is this pin, which is one of the heaters. This is the other heater, which is also the output of the cathode. And then here are the two plates tied together. These pins are all not used, so we're using them as tie points to connect the components together. Okay, so that's the wire that comes over to the choke. And we're connecting it to this pin here. We're going to put our resistance across between here and there. There we go. We got our 50 ohms of resistance going from here to there. Then our diodes going from here to there. Now all we have left to do is to hook up the plate to this side of the transformer and then the plates to this side of the transformer. And we've got plenty of this wire left over from our delay board. Now if you think for some reason, hey, I might some point want to put this delay board back in or something, you might want to just get some fresh wire, but I'm pretty sure I'm not going to be doing that. So we're just going to steal some of the wire left over from that other board and solder these in, and then we'll be ready to power this thing up and see what our voltages look like. Honestly, if I was ordering parts, the next time I make a parts order, probably going to get just a nice 5 watt 50 ohm resistor to put across there to make this a little neater, but I didn't want to make a special order just for this video. Here's that. And honestly, if you were planning on doing it like I'm doing, you wouldn't even need to unsolder this. You could just cut this wire that's going to the delay board and hook it straight to the transformer. Save you a soldering step. There's that one. Like I said, this other little wire here ties the two plates together, which is it's pretty unusual the way they wired this up, but we're going to take advantage of the way it is and leave these two rectifier tubes wired in parallel for the extra current carrying capacity that gives us, given that there's already holes there, and it would look kind of weird to just have one rectifier tube and have the other hole empty, even though one 5AR4 tube would absolutely be capable of powering this amp. But given that some of the modern 5AR4 tubes aren't really that stout, it's not going to hurt anything to have a couple of them in parallel. I may have soldered that other one up off camera. Whenever you're working with stranded wire like this, I'll always come in and tin the end of the wire so we don't have to worry about any little strands going somewhere we don't want them to. Probably not going to be able to see this, sorry, but... And there we go. And that's it. And if you want to, you can get some zip ties and zip tie all this stuff back together after you're done rewiring all of this. And as you can see, we left these 10 ohm resistors in because that just kind of helps the tube out a little bit from seeing excessive inrush current. And then these diodes protect the tube from back voltage from the caps, especially on a hot restart. That's something that can happen with these tube rectified amplifiers. If you turn it back on before the caps have drained, that can cause them to arc out too. So that should complete this. So let me pop the tubes in and we'll power this thing up and see what we've got. Okay, so we got everything all wired up now. I've got some dummy loads put on the output of the amplifier. Out of an abundance of caution, you should hook some speakers or something up. Given there's no signal going through it, it's not absolutely necessary, but again, just abundance of caution. It doesn't hurt to have a load on the amp. The other thing, we've got the negative lead hooked up to this ground right here. And then we've got the positive lead hooked up to the plate of the output tube so we can watch the voltage there using clips. So super safe. You don't have to touch anything inside the amp. You can hands free. So let's power this thing up and see what our voltage does. And what we should see is a very slow rise in the voltage here as the rectifier tubes warm up. And there they go. And you can see, it slowly builds up the voltage. And we have 413 volts on the plate. And let's see what it does as the tubes warm up. It might come down a little bit. And I'm not sure how this bias point is going to be compared to what we had previously. Let me go around here to the other side and see what that looks like. Yeah, the bias is set fairly cold. Let me reset the bias on this thing and we'll do one last check. Now that we know that everything's working right, I'll get the bias set right in the center where we want to see it, hopefully, and then hopefully that will pull down our voltage on the plates of these 300B tubes down to about 400 volts is where we want to see them. Okay, so I got the bias set in the center of the meter. May have had it biased for the electroharmonics tubes. Right now we have the Willsenton tubes in it. So dead center on the meter. Let's power this thing back up and see what kind of plate voltage we have now on our 300B tube. And then finally I want to measure the voltage drop across the 50 ohm resistor and see how much voltage we're dropping across it, and also making sure that we've got the wattage rating correct. Beautiful. There we go. Right at 400 volts, which is what we want to see on the plates of these 300B tubes. Some of the lesser quality ones have a max voltage rating of 400 volts. And so by doing this mod with the 5AR4 tubes and then this dropping resistor on the output of the rectifier, we're protecting the rectifier tubes from these larger filter caps, which do help get the millivolt ripple down to a reasonable point in the power supply, and then also gets the plate voltage where we want to see it. So super happy with what I'm seeing here. And this is what I had suspected we were going to see. And then the last thing I want to do, very carefully, put one lead on that side of the resistor. Again, I got my hand behind my back. You never want to have two hands touching the amplifier. And then let's see what the voltage drop is across these resistors. Well, as you can see, this fix wasn't very involved at all. And honestly, if you have one of the earlier versions before they put these delay boards inside it, you can probably just get away with dropping a couple of 5AR4 tubes in it and then setting the bias one little click mark to the left of center. You know, just slightly colder biased. Tubes are going to be running a little over 400 volts, like I showed in the last video. and it's going to be running a little under the 80 milliamps that straight up is, but it's within the dissipation of the tubes. They're still going to be running at 80%. Most of the 300B tubes should be able to deal with that, and you get the slow start of the 5AR4. Really, it's going to get you 90% of the way there. If you've got one of the later ones, this is a bad idea. And hopefully they'll stop putting these in here and start shipping them with 5AR4 tubes and adding the 50 ohms of resistance. That'll get the plate voltage on the 300Bs back to 400 volts, which is at 80% dissipation when you set the bias in the center, which is at 80 milliamps. The tubes are going to live a long time. You're going to have a nice slow start from these 5AR4s. That 50 ohms of resistance is going to make just a bulletproof power supply with these two rectifier tubes. Even using, new production, I think even JJ rectifier tubes would live in this situation, although I still wouldn't buy those. I would get Tube Amp Doctor, Sovtech, or Gold Lions. Gold Lions are what I use. They're a little more expensive, but hey, sometimes it's worth paying a few more bucks and not having to worry about stuff. Obviously, the new old stock 5AR4s are just bomb-proof. Whether they're RCAs or Mullards or Sylvanias, any of those old 5AR4s, just you can't blow them up. But they're expensive, and that's the deal. You're going to spend probably a couple $100 on a pair of tubes. And as lightly loaded as these are being in parallel the way they are, you really don't need them. Anyway, I think this was a good solution. Measuring the ripple with these big capacitors that you're using, I think you can get away with even using the choke that's in the amp. If you wanted to spend the money and do an upgrade, this isn't a bad thing to get one of these 194G chokes. They're, just a nicer made piece. They got a little more Henry. There's a little more resistance. Bring down the plate voltage just a little under. Probably end up with, 390 instead of 400, which isn't going to hurt a thing because that choke's got a little more resistance. But still put the 50 ohm in there between the tube output, the diodes that are there, that's shown in the schematic, and the first capacitor. So, anyway, I hope that helps people that have bought this amp. It's not the end of the world. This power supply thing is not a huge deal. The whole problem stemmed from trying to use these tubes. And honestly, I just think the amp looks nicer, not being so crowded, having these giant rectifier tubes in it, and kind of showcasing the 300B tubes and not having them crowded out by those big tubes. Plus, they're going to run cooler. The amp's going to run cooler because there's less filament current on these rectifier tubes, so the power transformer is going to run cooler. Just the whole amp's going to be happier. So the only thing else that I want to dive into is I want to play around to see if I can clean up that weird square wave I was seeing and try to see where that noise that we measured in the audio analyzer suite was coming from. Anyway, I think that's a wrap for this. Again, hopefully if you've got one of the later ones, it's not going to be too big a deal for you to ditch this board, do these little simple mods that I've done. And if you've got an earlier one, you can probably get away with just putting some 5AR4 tubes in it and running the bias a little left of center. So anyway, hope you're enjoying my channel. Hope you're enjoying this content. If you are, please subscribe. Please like the video. Thank you to you Patreon folks and also you viewers that send stuff like this to me to review and upgrade so y'all have some fun content to watch. And until the next video, have a nice day.